Hello everybody and welcome to another video brought to you by VEG TV. I'm your host, Jack. On today's video we're going to step outside of my boundaries just a little bit. This is going to work with SMD technology, and that's outside of my arena somewhat, but we're going to open it up and see what's happening. Primary complaint on this is, well, it's not working. Was working and go to use it. Nothing. Change the battery in it and still a whole lot of nothing. So with that said, let's go ahead and get cracking. Backside right here is the battery, and it takes a 2032 battery. Which for some reason I can't get out. It appears we just have 3 screws, and it's going to be a P1 screw, so a little screwdriver. And let's see how easy it is to open up. And there's the inside. So it appears that each foot has a pressure sensor on it. That's kind of retarded, but you know what I'm talking about. Our LCD display here, and then the guts of the board right there. And then a whole bunch of gobbledygook for wire. What's that? You want to look closer? Alright, let's zoom in. As you can see on the other side of your screen, the sensors for the foot, board for the battery, probably the brains of some sort, or just the LCD drivers. And if you notice on these feet, it appears that we do have a chip on a board. So you're probably asking yourself, Jack, what is your plan of attack? Well, that's a good question. I wish I had an answer. I don't have one. We're formulating it as we go. I think what we'll do is we'll take the benchtop power supply and we'll apply 3 volts to the board itself here and see what happens. If that don't work, then I think probably the easiest thing to do is take a voltometer and just follow these 2 power leads right here to ensure that we have no issue with them, and then we'll just work our way to the board here. We'll probably have to pull this board out. It is held in place by 2 P1 screws, and these 2 boards here with the ICs on them, they're held in place by silicone little splotches right here. I've got my cable plugged into the benchtop power supply, which is dialed into 3 volts DC, and I've got my continuity tester set here. Now, one thing that I totally glazed over, kind of important, is this right here. This is the power switch. So we will, of course, take a peek at that. That's just a momentary little micro switch thing, which you could see a little better there. So I'm going to hook up the terminals from the power supply to the battery, and as you can see, they are easily, clearly marked, almost foolproof, one would think. My power supply is protected, so if for some dumb reason the leads touch, the device under test should not blow up, nor should the power supply. So we got 3 volts there, not pulling any current. Let's flip it over. And look at that, we've got voltage. We've got a display. So this is going to be a pretty fast, quick, easy repair. So now we got to come back to the battery to find out what's happening there. Do we have a dirty contact? So I'll move that out of the way. We'll bring the battery back. Let's bring this over here. The big backside here is the positive and this is the negative. So as you see, we've got voltage. And no voltage. I don't see any issues with the contacts themselves, but let's go ahead and clean them. As you can see, they look pretty good. I don't see any corrosion. What we're going to clean them with is this fiberglass brush from Radio Shack. And of course you can't see what I'm doing because my hand's in the way. All I'm doing is just swirl motions. Take our vintage, I think it's either HP or Wang computer brush from the early 80s. Brush them right off. And still nothing. I know this is not much of a draw on the battery, but if I take a LED light, hook it up, you definitely see the battery works. So the next thing I'm going to do is I have jumpers, alligators, connected to the battery terminal of this device, and all I'm going to simply do here is take the other end and touch it and see what happens. Still nothing. So let me do this. Even though voltometer is showing I'm getting 3 volts out of the battery, let's see what it actually takes for the device to power up. Maybe we still have a weak cell. Alright, I know I don't have a camera on the power supply and you can't see it, so I'll yell it out to you. Right now we're at 0 volts. There's 1 volt. And so about 1.7 volts, that comes to life. And it just petered out there, so let's bump it up a little. Okay, it's 1.8 volts. That's 2 volts. So we have life at 2.2 volts, although it ain't doing much. I've got the power supply turned all the way up to 3 volts. Hit the power button. And nothing is happening. Disconnect the negative terminal. Reclip. And I've got power. Let me drop the voltage down. We're at 2.7, 2.4, 2.1. It's reading low. 2.3. I have to say this is really perplexing. I don't quite understand this. This should be theoretically straightforward, clean cut, a yes or a no, a 1 or a 0, but it's not. We've seen the old battery work just fine with a LED. However, put it in the device, it don't work. Again, voltmeter says it's fine, this little light says it's fine. I grab a new battery. This new battery, of course, is reading a little bit higher in voltage because it is new. And again, it works. I put it in the machine here, and it's still not enough to power on the device, even though I can confirm off of my benchtop power supply 2.4 volts is comfortable and adequate to power it on and make it work. This battery, I'm getting like 3.2 volts out of it. Just a hair more. It's adequate. I've got the jumpers plugged into the battery holder. And I'll hook it up right. As you see, nothing. So if I take and stack the 2 batteries, nothing. This has got me perplexed. I don't know what the issue is. Don't know what the breakdown is. Yeah, I forgot I wanted to do something, and that was to confirm, see if it really does have a voltage over limit. Now I know you can't see it on your screen, so I'll just holler it out. I'm just going to go straight up to 3 volts, which are right there at 3 volts. Let me go further. It's 3.3 and we lost it. So here I'm at 3.0. All right. I'm at 2.5. All right, I lied. 2.4. So that brings up a good question. Let me redo that. 3.1. 3.2. 3.5. Okay, well if it's holding at 3.5, then what happened a moment ago, and then why not taking the 3.2 battery? So it's not an over voltage issue. There's 3.8. There's 4.0. It should have took that battery. So it's not an over voltage issue. And it's saying I'm low at 2.3. I got to think about this. After giving this some thought, what the cause and effect could be, what I've tried, what I haven't tried, and all of its goofy insanity, I come to the conclusion that when I bellowed out, gosh, could this be a quick and easy resolve? Turned out the answer to that is no. No, it's not. My voltage was adequate. As you see, the display is illuminated. I'm at 2.5 volts. Either one of my 2032 button cell batteries should have illuminated this. So I started thinking, well, gosh, what other strange forces are in play here? Well, it's current. So I had to go Google how much current one of these little batteries offer. And the answer is, on this 2032, it's 220 milliamperes. So with that in mind, I went and set up my power supply to that, and the device fired up just fine. So the next step was, okay, exactly and how much will it take for this to work, to illuminate? And the answer to that is exactly 161 milliamp hours. I'm curious, how much is those putting out? This project has really gone on for a long time. So I think maybe the simplest answer, simplest resolve, just go get another battery. We ain't got another battery. So let's give this a shot. I've unplugged the power supply. Here we go, ready? Hey, look at that. That worked. Of course, let's get it in the hole properly. So there we go. That is how it's not done in Dixie. We'll reassemble this. There you go. We may not have learned anything in this video, but one thing I can guarantee for sure, this was a time-wasting video. Some of you may or may not approve. I'm okay either way. That'll conclude it for me on a super cool video. At least I think so. My best one by far. Thanks for watching. I do appreciate it. And thank you to the massive influx of subscribers I've received here lately. Greatly appreciated. Catch you in the next one. Bye.